Today we're going to be talking about exponents and multiplication. This is multiplying powers with the same base. So let's do a little bit of review before we get there. Exponents are used as mathematicians' shorthand for repeated multiplication. Remember, I keep telling you that we mathematicians like to keep things short, make things very brief. We want to shorten them as much as possible. So let's look at this first example. This is what we had done yesterday. X times x times x times x times x times x will get us x to the 6th power, because there's 6 x's there. They're all being multiplied together. Our next example, we have 5 times 5 times 5, a times a times a times n times n. Well, that's going to be 5 times 5 times 5 is 125. We have 3 a's that are all being multiplied together, so that's a cubed, and we have 2 n's being multiplied together, so that's n squared. So the simplification of 5 times 5 times 5 times a times a times a times n is 125 a cubed n squared. That's just a review of yesterday. So what happens if we multiply two powers with the same base? For example, we have 7 squared times 7 cubed. Well, we all know that 7 squared is 7 times 7. We're going to multiply that. Here's our multiplication sign here. We're going to multiply that times 7 times 7 times 7. What do we have there? There are 5 sevens being multiplied together. So that's 7 to the power of 2 plus 3, or 7 to the 5th power. So notice what we did. We wound up just keeping our base the same of 7 and adding our two exponents here, 2 plus 3, to get 7 to the 5th power. And that actually, if you look back here, we have 7 times 7 times 7 times 7 times 7. So it's pretty easy to see when we are multiplying two powers, all we do, if they have the same base, they must have the same base for this to work. The base is the same. We just add the two exponents, and we get 7 to the 5th power. So here's our rule. To multiply numbers or variables with the same base, just add the exponents. Here's 2 to the 3rd power times 2 to the 4th power. That would be 2 times 3 plus 4, or 2 to the 7th power. If you needed to see what that looked like, we have 2 to the 3rd power. That's 2 times 2 times 2. And then 2 to the 4th power, which is 2 times 2 times 2 times 2. And when we count them all up, we find out it's 2 to the 7th power. Easiest shortcut, just add them together. If we were working with variables, if we have a as the same base and an exponent of m on one and n on the other, the exponent would be m plus n. So this is for all positive integers. There's our rule for multiplying powers with the same base. You should write this example, the 7 example, and the rule in your notebook. Okay, so if we're going to simplify expressions, that means to simplify an expression means to do as much math as we can possibly do. So in other words, if it says to simplify each expression and we have 3 times 3 to the 3rd power, what are we going to do? Well, we notice first that the bases are the same. We have 3 and 3 as a base. So we know we've got a 3, and then we're multiplying that times 3 to the 3rd power. This 3, what's its exponent? Yes, you're all thinking it's 3 to the 1st power. So with using the rule that we just learned, this would be 3 to the 4th power. We can prove it out by looking at 3 and then multiplying that times 3 times 3 times 3. Oh, look at that. That's 3 to the 4th power. I didn't want to have to do all of this. I can just look and see it's going to be 3 to the 1 plus 3 power, or 3 to the 4th power. Let's look at an example with variables in it. I don't know if you can see it from the back of the room, but it says a to the 5th power times a times b squared. So we're going to remember the bases have to be the same. This is an a and this is an a. This is not an a, that's a b. So we don't want to combine that, but we can combine our two bases. This is a to the 5th power. This is a to the 1st power. So when we combine these, we have a to the 5 plus 1 power and b to the 2nd power. Well, 5 plus 1 power, that's 6, so we have a to the 6th power, b to the 2nd power. I have simplified this expression. So let's do couple quick checks more. Do these in your notebook. You may stop the tape here while the students complete the examples. 2 to the second power times 2 to the third power. Let's use our rule. Our base is the same, so we have a base of 2, and we have our exponents that we can add together, so that's 2 to the fifth power. Second one, we have the same base for each one, that's m. 5 plus 7, m to the 12th power. And this last one gets a little bit more complicated. We've got a couple x's and a couple of y's here. Remember, we can only combine like bases, so we've got x, and we've got to the 2 plus 3 power, or 5x to the 5th power, y to the 1 plus 4 power, that's y to the 5th power. Hopefully all of you were successful in completing those exercises. Of course, just wanted to show you using the commutative property, how that can help you. Here's our example, 2x squared plus 3x to the 5th power. 2x squared plus 3x to the 5th power. I've got some variables and I've got some numbers and I've got some exponents there. I want to combine things that are alike. So I'm going to write them next to each other because our commutative property says we can put any of these terms in here in any order we want to. So we have a -2, and we're going to put our whole numbers together in the expression. So -2 times 3. And then we have x squared, and we have x to the 5th power. All I did here was rewrite them so I could see what was alike. Now I can do, and simplifying does any of the math I could possibly do. So I know -2 times 3 is -6. Then I can look at my exponents here, my variables here. I have x squared times x to the 5th power, so that's x to the 2 plus 5 power. So the simplification of -2x squared plus 3x to the 5th power is -6x to the 7th power. We're just going to quick look down here. Let's just do letter B. So we're going to use our commutative property, and we're going to put the things that are alike next to one another. And then we're going to continue that process, putting the things that are alike next to one another. Now it becomes easy to see what we need to do. -5 times -3, +15. C squared times c to the 7th power, that's c to the 2 plus 7th power, or 15c times c, 15 times c to the 9th power. All right, as if things aren't complicated enough, well, before we get there, here's a hint. I wanted to tell you this. When in doubt, write it out. If you're unsure about the rules, you're not sure what you're going to do. Like, for example, this one, this 5 times -3, -5 times -3, I know it's 15, but if I'm not sure about my c's, well, let's write them out. I've got a c times a c, and then I've got 7 more c's here. How many total c's do I have? 1, 2, 3, 4, 5, 6, 2, 3, 4, 5, 6, 7, 8, 9. I have 9 c's, and look at, that's what I wound up with here. So when in doubt, write it out. Notice that all of these c's simplify to c to the 9th power. Okay, so if it isn't complicated enough, let's look at this. We have 7 squared, and we're going to take that to the 3rd power. Well, we all know that would be 7 squared times 7 squared times 7 squared. If I write it out, it's 7 times 7, 7 times 7, 7 times 7. So in other words, 7 squared to the 3rd power is 7 to the 6th power. And that looks a little different. Before, I just said I was adding my exponents. Remember when I was adding the exponents? I had 7 squared times 7 cubed. This would be 7 times the 2 plus 3 exponent, or 7 to the 5th power. But that's not what I've got here, is it? I, in this case, have 7 squared to the 3rd power, which means I have 3 groups of 7 squared. So I have my 3 groups of 7 squared, and then when I simplify it, so in this case, this is called a power to a power. Power to a power. So we're having an exponent here and an exponent on the outside of the parentheses. So let's go on, we'll do one more example of this. We have 3 squared to the 3rd power. So that means, that means 3 squared times 3 squared times 3 squared. Well, I know if I have 3 squared times 3 squared times 3 squared, that's also 3 times 3 times 3 times 3 times 3 times 3, which is also 3 to the 6th power. What had happened? I just simply multiply. I could just simply, as a shortcut, multiply the 2 and the 3 together. I can multiply the exponents when I have a power to the power. So multiply exponents when we have a power to a power. Pretty exciting stuff here. So let's look at this first example. If I'm going to simplify this, multiply, I've got a 2 to the 4th power squared. So I've got a power to a power here, don't I? Let me write it bigger for those of you in the back of the room. This is the value I have. And we said, okay, if I've got a power raised to a power, I can just multiply those exponents. So I have 2 to the 8th power. Next one, letter B, I have C to the 5th power, raise that to the 4th power. So of course that's C to the 20th power. If in doubt, write it out. I could write out on this one 4 groups of 5 C's in a row, and I would find out I have 20 C to the 20th power. Now when I have a variable, well, I've got my M, multiply those 2 exponents, I have M to the 6th power. So as you can see, we've got several things that we've done today. The things that we've done, and 3. We started out today just talking about what exponents are. Let's x to the 4th power means x times x times x times x. And then we said what happens if we have x to the 4th power times 5 times x times 2. Well, I can simplify that by putting like terms next to each other using commutative property. And I find out what I have common bases. I can add those exponents. So I have 10 times x to the 5th power. This was when I have exponents next to each other, common base. And now this last one, when we took a power to a power, we did x4 to the 7th power. That's equal to 7 groups of x4, 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 x4. Do I have my 7? I think I do. And what is that equal to? X to the 28th power. So hopefully this makes a little sense to you. I'll post this video on Edmodo as